All right, y'all. Hello, hello. Welcome back. We are really jumping in today into two-way frequency tables. We have talked a little bit about percentages, and that is some of the math that we're going to need to roll over. Let's start by taking a look at the rewind questions today. First one asks, what is the probability that a marble drawn is green? Okay, so this is just a simple probability question. What we have to look for is how many of the marbles are green. In the table, we notice that's 8. Okay, so we have 8 green marbles. That doesn't answer the question though. The question asks, what is the probability, right? So we have to answer this a little bit differently. It's 8 marbles out of a total number, and then if we add all these up, we get 25 total. Okay, we can answer this as a fraction, 8 over 25, but we don't usually express probability that way. We usually express it as a percent, right? What's the probability that it's going to rain today? 50%, 75%. Those are the types. Those are the types of ways that we express probability is through percents, right? So it kind of comes into play with the math you guys were doing on the Oregon Trail the other day. If I divide these, I get 0.32. Right, and we know that 0.32 as a decimal is the same thing as 32%, right? So if you drew out one marble and put it back and you did that 100 times, you would get 32 marbles, or near 32 green marbles. Okay, and then the second one here is a double distribution problem, which is something that we haven't looked at for a little while. Remember, when we multiply here, we basically just have to take the first thing and multiply it over, and then the last thing and multiply it over, right? So 8v times another v gives us 8v squared, right? And then 8v times -2 is -16v. We're halfway there, right? We need to double distribute, which means we also need to multiply our 7. And it's not just a 7, it is a -7, right? The negative goes with the 7, so that gives us another -7v and a positive 14, okay? This is a fine answer, but we haven't combined our like terms. 8v squared, we only have one thing that's a v squared, so we're just gonna write that again. Okay, but these ones here have the same variable and the same exponent, which means that we can combine them, which gives me -23v, and then we still have this 14 hanging out there. Okay, you should have gotten 32% and 8v squared minus 23v plus 14. Okay, let's see, I'm gonna keep this video rolling for just a second. I'm pretty bummed you guys aren't here with me in person today. This is one of my favorite lessons, and it's a lot easier to teach when there's students sitting in front of me, okay? We're basically going to start looking at these things called two-way frequency tables. So I want you in your mind to answer 2 questions, okay? Were you born in Seattle? Okay, that's a yes or no question. And were you going to be in the musical? Okay, each one of those questions can be expressed by a yes or a no, and we can basically put that data into a table that we can use to answer all sorts of questions, okay? So let's go ahead and let's include some labels on that table, okay? So let's pretend, let's see, maybe let's pretend Diego was born in Seattle and he was going to be in the musical. So maybe Diego goes here. Okay, maybe Willow was not going to be in the musical, but she was born in Seattle. Okay, maybe Aaron was not born in Seattle, right? Like, so just pretend everybody in our math class gets put into one of these squares. And what we might end up with, maybe we've got a total of like 7 people who were born in Seattle and who were also in the musical. Okay, maybe we've got 13 people who were also born in Seattle, but these people are not taking part in the musical. Maybe there's only 5 people who were born someplace besides Seattle, but are not in the musical. I'm one of those people. I was born in Spokane. Deal with it, okay? And then down here, we've got musical and born somewhere else. Maybe let's say that there are 10 people there, okay? Maybe that represents our class. Maybe it doesn't. I just kind of made up those numbers on the spot. But we can use this structure called a two-way frequency table to kind of organize our thinking and help us answer a bunch of questions about our group of people, okay? The reason we call this a two-way frequency table is because we have included some extra spaces here around the outside edge. And those extra spaces will help us answer questions like this one. This one says, what percent of kids in the musical were born in Seattle, okay? Based on what we have right now, that question might not seem super easy to answer, but if we go ahead and we figure out the numbers that go around the outside, this problem becomes a lot more doable, okay? Basically what we can say here, how many kids were born in Seattle? We've got 7 that are in the musical, 13 that are not. That means that there's a total of 20 kids that were born in Seattle. Okay, down here, not born in Seattle, we've got 10 and 5 more. So there's 15 kids who were born somewhere that's not in Seattle. Okay, same thing the other way, 17 kids in the musical and 18 kids who are not in the musical. And if we do a little bit of math, this bottom square here, that's just everybody. So you can do it this way, or you can do it this way. We have a total of 35 kids in this completely made up sample in front of us here. Okay, the reason these are so helpful deals with this magic word, okay? We have a magic word today, you guys, and it's not please. Our magic word today is of, okay? If we can zero in on that little word, it's going to help us answer questions just like this one, okay? So I want to come back to this. What percent of kids in the musical were born in Seattle, okay? So the word of kind of cues us into the group that we're talking about, okay? And in this case, it's not just kids, it's kids in the musical, okay? So the kids that we're looking at are just the kids that are in the musical. So if we go over to our table, how many kids are in the musical? I see that there are 17 kids in the musical, and how many of those kids were born in Seattle? Right, here's our 17. Of those 17, we have 7 who were born in Seattle, okay? And then we can pretty quickly turn that into a percent by just going 7 divided by 17, which gives us 0.41 or 41%. Okay, so again, I filled out this two-way frequency table to kind of go along with the questions I knew I was going to ask. And then I can just kind of pull out the important information. Of is our magic word. Anything that comes after of is the group that we're looking at. It's our denominator. And then the kids that were born in Seattle that are a part of that group are going to be our numerator. Okay, and I can ask you a ton of different questions from this one table. Okay, instead of that question, what if I changed it up a little bit? Okay, this last one was 41%. Okay, for this next one, what percent of students who were born in Seattle were in the musical? Okay, I'm using a lot of the same words in this question, but because the order has changed, the question has 2. So I'm going to zone back in on my magic word. What percent? Oop, there it is. Of. Okay, and then this says students who were born in Seattle. Okay, so this time I'm going to have a different total. The number on the bottom is not going to be 17. Take a second, pause the video, see if you can figure out what the number on the bottom needs to be. Okay, so the number on the bottom here is the students who were born in Seattle, right? And if we look at born in Seattle, we've got 20 kids who were born in Seattle, okay? And then how many of those were also in the musical? Let's see, here's our born in Seattle. Again, it's 7. But this time our number on the bottom is different because I asked the question in a different way. Okay, once I get my fraction, the hard work is done, right? I just have to divide on my calculator. So 7 divided by 20 gives us 0.35 or 35%, right? I multiply it by 100 because it's a percent, okay? So we have a couple more here. I want you to pause the video and see if you can solve this one before I get to it. Okay, pause the video, see if you can solve this one. What percent of the class were born in the musical and born, I read that wrong. What percent of this class were in the musical and born in Seattle? Okay, again, we're gonna hone in on our magic word of, and after of is this class. Okay, how many people are in this class? That's everybody, that's all 35 students. Okay, and then this time we're looking at people who were in the musical and born in Seattle. That's this same little square here. So we're still using 7, but we've changed the number on the bottom. Okay, so then again, I'm going to grab my little calculator. 7 divided by 35 gives us 0.2. Okay, be really careful with this. This is not 2%. Remember, I have to move it 2 spots. This should be 20%. Okay, and then one last question to walk through. Again, I'd like you to pause the video and make sure you can get the same answer as me. What percent of this class was born in Seattle? Pause the video. See if you get the same answer that I do. Okay, for this one, I'm going to hone in on my magic word of. What comes right after this class? Again, we're going to be using 35 on the bottom, but this time it's asking was born in Seattle. Okay, so out of everybody in this class, how many people were born in Seattle? I've got 20 people that were born in Seattle. My fraction is 20 over 35. And when I turn that into a percent, I get 57.1%. Okay. Like I said, I wish you guys were here. This is a really fun lesson to do in person. It's a little tough to do over the internet, but I hope that this example set kind of makes sense. Let's see, coming after this, we've got Pick'em. So I'm going to leave this slide up in the slideshow, and I would like you guys to pick one of the 4 problems here on the right-hand side and answer it using this two-way frequency table that I've provided, okay? The 2 at the top are a little easier. They get harder as they go, okay? So pick any one of these problems, figure out what your answer would be. I'm gonna have the answers up on the board to start the next video, okay? And I will check in with you guys then.